Okay, hi, this is Jeff Morris, Head of Marketing at Datacoral, and I'm sitting here with Nitin Bose, who is in charge of our field marketing team.
Hello, everybody.
And today we want to talk about what does Datacoral really do?
So the way we see ourselves is providing a data infrastructure as a service. End of the day, we see ourselves making data engineers, data scientists, and data analysts a lot more productive, self-sufficient, so they can go back and focusing on adding value to their business rather than building the plumbing that comes along with setting up data pipelines.
And I like the pipeline metaphor a lot because oftentimes, you look at the way data flows through an organization, the metaphor really works well. So when we describe it, we talk about allowing, let's say, data scientists or even data engineers to work inside the pipeline on the data itself, not around or the outside of the pipeline and the scaffolding of the pipeline.
That is correct. And we have specialized in becoming really good plumbers, and we've done so for many decades now. And that's one of the things that we differentiate ourselves to have known how to best lay these things out. We have a very opinionated way of how to set up ELTP pipelines end to end. And that way, when the analysts are working on a specific business case, they're actually able to solve that business case without dealing with the drudgery that comes along with the pipeline build itself.
And that background includes experience at the big 21st century unicorns, right? Like Yahoo and Facebook and Groupon, those kind of organizations.
That's correct. That's correct. And our founders actually have written up, basically contributed to the code for Apache Hive, as well as a lot of open source contributions in the data space as well. So we've been in the space for a long time now.
Yeah, a couple of decades practically, yeah. Okay, let's continue.
And the way we approach enabling data pipelines is an end-to-end stack. This entire end-to-end stack gets enabled within a customer's AWS VPC. The reason why we have chosen to do this primarily because data has become a lot more important and more sensitive. Privacy aspects are adding a lot of constraints on organizations. And the last thing that companies have to worry about is having a third party manage their data and potentially end up with data breaches that they now are answerable to their customers about. So what we have taken is an approach where all of the data that the customer has to collect, organize, and harness actually gets set up within the customer's AWS account. That way they have full visibility to that data, have full control over that data, and they can manage it with the highest level of security that's appropriate for them.
And ultimately, the permissions that we get on the data is, again, from the outside. And so we never see the data values. We see metadata, perhaps, or query definitions, perhaps, but none of the data values themselves.
That is correct. So we have ability to be able to deploy our software, and that's where we come in and provide Datacoral as a software stack, which gets deployed within the customer's account, and then it's executed within the customer's account. The data always stays within their VPC, encrypted, without us being able to look at it or analyze it.
That's very cool.
Part of that whole pipeline is for able to assemble microservices, which are the building blocks of this entire stack. We have built special purpose microservices to be able to bring data over from wherever they are. This is what we call as the collect slices. We spend quite an amount of time building this capability around transformations, where we can take data that's already landed in a warehouse and in place transform them with the least amount of effort. This is the part that we differentiate ourselves from the rest of the market, and where we have uniquely positioned to be able to get the lowest amount of information that's needed to be able to build a production grade pipeline and allow the analyst to focus on the business value versus the plumbing itself. And we'll see that quickly. Once you have that data transformed, we also allow for publishing that data over to SaaS APIs or databases with the intent to be able to run end-to-end pipelines without human intervention.
Yeah, and that's one of the, I think, the biggest differences from a lot of ETL or ELT or data integration vendors is they forget about the last mile part of publishing the data to somewhere else and continuing its use downstream, even when it's outside of the data warehouse or outside of the data lake kind of thing.
Absolutely, and as teams mature, the data stack that's with them has to mature and cater to their growing needs versus limit their opportunities. Mm-hmm. And we have been able to support for scales much beyond some of the teams that we have supported but they are now ready to take that next leap of faith. So let's just quickly dive through what is under the covers. We provide about 70 some slices, our connectors, which are out of the box. We can read from databases, we can read from SaaS APIs, we can read from file systems, or we also support eventing for being able to get streaming data into the pipelines. We have a series of query engines and warehouses that we support. We are always adding new ones, and we also allow for publishing data back out into databases and APIs and files. So at the end of the day, we're providing the end-to-end stack for customers to be able to set up their own use cases with the least amount of effort.
What's interesting about this list of organizations and products is this is really a who's who of what's online right now. Across the board, whether it's in social media, whether it's in the AWS series of products, or in the MarTech stack, other cloud stacks, it's really quite incredible here.
Yes, and to add to that, also engineering has been heavy users of our platform, being able to get instrumentation, looking at their source code, looking at their uptime. So it's both functions of front of the house, sales and marketing on the field side, as well as internal analytics and operational excellence. Bringing data into the platform is actually pretty straightforward. It really is a series of CLI commands that you're enabled to do so. The reason why we've done a CLI first approach is primarily because we believe in data ops being no different from DevOps, and data operations and data artifacts being no different from code artifacts and config artifacts. And everything we have done, we have kept to engineers. And so they actually can collaborate, set up these end-to-end pipelines, have peer reviews going on, and take that output that has been produced as analysts and engineers able to create, and then automatically integrate into a CI/CD pipeline and run commands which look like this on the screen to instantiate and onboard brand new data sources.
Mm-hmm. Yeah, I think that's arguably one of the more compelling reasons for an organization to adopt this is not only are we trying to automate and make the whole data pipeline easier for you, but you're never losing any of that deeper level control over the environment.
Correct. Once you actually instantiate or run these commands, what's happening underneath the covers is really the lambdas and the serverless microservices coming to life. At this point in time, we've just added a database slice which has gone in and reached into that particular endpoint, figured out all of the tables which exist within that schema, what is the size, shape of those individual tables, and apply heuristics to figure out what is the best way to bring them over. Small tables are best brought over every time. Large tables are best when you're incrementally bringing the delta of what has changed the last time you pulled. All of those heuristics are automatically applied. This is best effort, as you can imagine, based on the tool's knowledge of the metadata. But engineers always have the control to come back and fine-tune this because they know their endpoints a lot better than a system ever would.
Sure, and of course, telegraphing the next set of exercises here is not all these data sources operate on the same timings.
Correct. Some data might be changing every few minutes. Something might be changing every day. So you can fine-tune what is appropriate based on the use cases that you drive. At the end of the day, we want to bootstrap all of the underlying plumbing and give the analysts and the engineers the level of control, but not the burden that comes along with it.
Right, and that's a really good way to put it, is you get the control when you need it, but none of the burden of having to drive it. I really like that.
Correct, and life never stays static, and things change as your source systems continuously change. The pipelines actually detect that and start bringing data that changes over, and that's extremely important because the last thing you want to do is set up these world-class pipelines which are brittle. The last thing we want to do is come back and maintain it. So our pipelines are set up to be able to understand the change and propagate them through the pipeline.
Well, and how often does Salesforce or Zendesk ever tell you when they're going to change their schema? Never, right? So you have to have an environment that will detect that automatically.
Yep. Underneath the covers itself, we actually do a lot of microbatching, trying to optimize the best way to bring data over, especially if you have large-scale data sets that you're trying to bring over. We'll actually do checkpointing within the pipeline so that if anything happens with respect to the source system going down, network failing, we actually have mechanisms to recover really quickly as well. This has a side effect also, as you can imagine, to not apply undue burden on the sources. So if you're running a production workload, your primary database is not bogged down by the fact that the pipeline is trying to suck data out of it.
Mm-hmm.
That's awesome. So what happens after you're able to bring data over? It actually all lands up in Amazon S3, in your own bucket with fully open formats, encrypted nevertheless, but fully open formats. So you have always full control over the data. You can look at it, you can use different tools and engage with the appropriate mechanism. You're no longer limited because the formats are proprietary. All of the data is laid out in this, what we've seen as the best practices of partitioning on source, sensitivity, time. That way you can actually utilize higher level controls of not just access policies, but also with respect to time to figure out how do you want to see data as it changed over time. Do you want to look at it as of right now? All of those possibilities become available immediately.
And then as you dive into it, you're using, as we're showing right here, Athena's native query editor on top of all that data. So you're never really lost with regard to your choice of query engines, your choice of query targets, and where ultimately where the transformations happen, Redshift or Athena or other data warehouses.
That's absolutely correct. So the same thing goes for Redshift. So we can actually bring the data over to Redshift directly. Again, we've taken the approach of extract, load, and then transform.
Mm-hmm.
We want to make sure that there's a high fidelity 1:1 mirroring of the source. That way you can ask different questions because you never know what new use case you want to dream up. And so we've allowed for that EL-based approach of landing data. So trying to just summarize what we've gone through for the past 5 minutes, you run just literally just one command to say, bring new data from MySQL, and you have your pipelines being hydrated through the Datacoral stack and landing data into data lake and landing data into data warehouse. How cool is that?
Yeah, no, I think that's awesome. And again, the landing in the lake for persistency, for persistence sake and posterity, and then landing it in the data warehouse for manipulation, transformation, et cetera.
Right. Let's actually get to the meat of the product. This is where we really dial it up with respect to taking the concepts of the least amount of specification that we need from an analyst or an engineer to build pipelines. And often it's as simple as expressing SQL. You can take your data that's coming in the raw format, transform it, aggregate it, you do your old school Kimball modeling. Regardless of what you are trying to do, most often you can express it one of two ways, one of them being SQL. We'll get to the second one later. But if you take that SQL, you've written that up as an analyst with your favorite query tool, you take that exact same query, which runs on, let's say, Athena or Redshift, and apply decorations on top, which actually illustrate the behavior you want this transformation to have. In this case, I'm saying, please run this every 4 hours, and you invoke the Datacoral API to say, please create a materialized view. What we really are doing when you run this is introspecting that SQL, understanding what it's trying to do, and think of it as almost as an explain plan method, building a DAG automatically from that SQL. That customer health had 3 upstream dependencies, looking at billing and Zendesk and events. They themselves were intermediate tables, and they were reliant on 6 upstream tables. The user at no point in time built the dependency by hand. It was all derived based on the business logic they're trying to execute. This is the dynamically building DAG and executing that we are actually really proud of, because it's taken us quite a bit of effort to be able to produce this. This means that you don't have to worry about ETL jobs anymore. There's no dependencies that you have to hand wire. There is no defensive code you have to write to be able to manage data coming at different frequencies. All of those things are taken away because this DAG gets built from the SQL spec and gets executed when the data becomes available.
Yeah, I think that to me was the most compelling thing about the product overall, was that you instantly had all of that information both available to you. You can imagine applying it in different areas like data governance kind of situations or data provenance situations where you need to know where something came from, when it arrived, what its sourcing was. If you're trying to support, let's say, the California Data Protection Acts, the Data Privacy Acts that have just been gone into effect. All of that really depends on this kind of data lineage capability and knowing how everything flows as it's flowing, or when it flowed, or if it stopped flowing.
Correct. And typically people use documentation to
Right.
be able to answer those questions, and I've done so, mea culpa, but because those are the tools that were available. However, if you no longer are looking at documentation which is outdated, but looking at live pipelines and deriving lineage, there's no better answer than that.
Yeah, that's really awesome.
So having a simple DAG which manages one-to-one dependencies is the first order of business. But things get really complicated when real life takes over. Data does not show up in the same frequencies all the time. You need to worry about data showing up at different frequencies and synchronizing them all to run your logic. This is where the engineers today have to spend quite a bit of effort to be able to manually wire the number of upstream dependencies that successfully I should have finished before I run my transformation. Everybody's done that. Nobody likes it. What if that level of burden and cognitive load was taken away from that engineer or analyst, and the platform figured out because it knows the upstream dependencies. It knows how often the data changes and comes into the pipeline. It also knows the state of whether this particular step finished or is still in progress. And that drives the rest of the DAG's execution.
That's very cool too.
And I touched upon the fact that there's provenance and lineage that you can actually benefit from. And there's another aspect besides compliance that this actually comes in handy. If you're an analyst and you're trying to understand what is the most recent data that I'm looking at right now, you no longer have to ping your data engineer on Slack to figure out, hey, what happened in your code? Did it actually finish? All that back and forth is inefficient, to say the least, and it's a burden for both the teams involved. What if the analysts could answer themselves as to what data came in? How much data did we bring in? And what am I looking at right now? Is there an upstream step that actually failed? Oh, that is truly the self-service of data. It's no longer just about having access to it, but also knowing how good the data is.
Yeah, and it eliminates that skepticism that people have about, is this the right data I should be working on? That how fresh is it question is arguably maybe one of the first two questions you ask about. Does it got the right fields in it, and then how fresh is it? It's really the order of precedence that you look at information like that when you're as an analyst or as a data consumer.
And not just changing, let's say you're running a specific DAG, but also when you're trying to change some part of the DAG, we consider that as a change. Think of it as a database commit that you're trying to apply. You could be committing a change to a single node, or you may be applying a change to a part of the DAG across multiple nodes. And when you do so, we automatically detect downstream dependencies. Will the pipelines fail based on the activity that you're trying to perform? And the platform is built to be able to tell you
that information. That's really cool.
Once you say, yes, I know there are downstream dependencies, you can bundle them up into one commit, quote unquote, and apply them as a set. And that's where you're now dialing up the efficiency you can get from the engineering and the analyst team. Not everything, however, can be done with SQL. This is where we've extended the whole concept of DAG, not just to run arbitrary SQL, but also run arbitrary Python code that you can embed to do things like machine learning. You can apply user-defined table generation functions, aggregation functions. You can use it to encrypt, decrypt particular columns based on your specific scenario. There's a lot you could possibly do.
Your Python library full of algorithms and your own predefined functions. Then you can incorporate that into this data pipeline. So the data scientist is continuing to really just focus on the data itself, how they want to be manipulating it in every experiment, and it just works within the pipeline.
That is correct. So productionalizing data models is a different beast by itself. And what we have done is we have made it simple to run through the rest of the pipeline just like anything else would. And it's in context. It will work on modified data or new data that came in. It will apply its inference, take the output, make it available as another table for the following step in the DAG to pick up. And this is where you can really ratchet up the efficiency gains that you have from it. It's awesome. If you want to connect directly to that data in the warehouse that is already transformed using the likes of Tableau or Looker or Periscope, you can go to town. But oftentimes teams actually graduate up from it to be able to push data back into where the users really are. And this is where the hardness slices, the publishers, come into effect. It's primarily the inverse of the collect slices. They take data from a warehouse or a lake and push it to endpoints. you do something similar to for the collect slides, where you do some level of mapping to say, here's what the data I'm trying to take, and here's where it needs to go. Again, in plain simple JSON format that you can easily source control, and you apply as a harness slice, and eventually you'll actually have ability for you to build dashboards within your endpoints. This is clearly an example of a dashboard built on Salesforce, not built by us, but it can power a dashboard which is built not just in dashboard in Salesforce, but also in a variety of different tools that you have. But more importantly, it's powerful when you can apply the same concept for, let's say, end-to-end campaign automation. You want to, right?
Yeah, it's the the ability to have distilled the data into exactly its form that you wanted to have it in, so that it does feed your operational applications. It could feed your revenue generating applications if you were trying to update behaviors of a customer that just placed an order with you. Those kind of things. Yeah, this is really the end-to-end part of that of the pipeline story. And as I've seen in my career, this is the forgotten piece that most vendors, either in the analytics space, the data warehousing space, or the data integration space, they all forget. Right? They leave that part of the problem up to the Accentures and the EYs of the world to handle, because they often say that it's not something that they can anticipate. Right? And I think that was just wrong, or that was a turn of the century thinking kind of thing.
Part of it was the limitations of what technologies were able to offer. Clearly, we've moved significantly further from then on, and that's been the genesis of the product that we've built, which is take the data that you have, manage it within your account, and use these building blocks that you can define through declarative approaches, assemble them as appropriate for your particular use case, and have that give you a secure production grade pipeline that you can rely on. And there's a team, in this case, primarily providing the 24/7 operations and the monitoring and the end-to-end aspects of the TLC that comes along with it.
Yeah, that's again, the end-to-end piece is I think is really fantastic, and the punchline of your own secure data infrastructure stack that both is supplied by a vendor that you can depend on, who has done this for almost 2 decades in the past. But then it's also always under your own control in your own AWS account. It's safe and secure as you would expect it. Yeah, I think this whole exercise of enabling true self-service is a big value that we're able to provide.
Great. I'd like to hear more if there's interest from the community.
Yes, so absolutely. So this concludes our presentation. Please visit datacoral.com if you would like to see this live happening in your own environment. Nitin, thanks very much.
Thank you, Jeff.